Hi, I'm Jody DeYoung-Hughes, soil scientist from the University of Minnesota Extension.
And I'm Jared House, Administrative Manager at the Grant County Soil and Water Conservation District. In September of 2020, we held a Soil Health Expo near Barrett, Minnesota on the Rolofson family farm. We wanted to look at how to use cover crops and reduce our tillage to minimize soil erosion and improve the health and productivity of our soils.
The health of our soil depends on many factors and can often be complex and confusing. That's why in this series, we will discuss common soil issues and effective management tools that can be used to successfully implement reduced till and cover crops. Each video can be viewed independently or together for a more detailed look at soil health management.
This is the first video in the series. In this video, we will discuss why it is important to use cover crops and leave residue standing. This has to do with the very important topic of soil erosion. Jody, can you explain to us what is soil erosion?
Sure. Soil erosion is the wearing away of topsoil, taking nutrients and organic matter with it. It can be moved by the wind or water and is intensified by tillage. Jared, did you know that the wind will start moving soil particles in as little as 13 miles per hour?
Which I think happens almost every day in western Minnesota.
Seems like it. In the upper Midwest, erosion due to wind is most prominent during the late winter and early spring months. The soil is left unprotected after fall tillage until crop canopy closure in late June. This can leave the soil uncovered for up to 8 months. Large, flat, unsheltered fields and clayey soils with little residue are the most susceptible to wind erosion.
How does that differ from fields that are susceptible to water erosion?
Water erosion is predominantly on slope fields with little residue. Water erosion happens during snowmelt and high-intensity rainfalls when the soil is not protected by the crop canopy or residue.
But there has been some good news over the past 40 years. Soil erosion rates on croplands have been reduced over 25% using various soil conservation technologies. This includes reducing tillage or no-till and adding cover crops.
Yes, however, even with the decline in erosion, soil is still being lost at a rate 10 to 15 times above the rate we can replenish it.
Isn't soil erosion a natural process?
While erosion is a natural process, cultivation of the prairie in the upper Midwest and the dominance of annual crops have significantly sped up soil loss. Some estimate as much as 19 inches of topsoil have been removed from agricultural fields. This severely diminishes the productivity of our soil. While we can't change the weather, our soil texture, or the slope of our fields, we can control how easily our soils will erode.
I've been hearing from farmers and researchers that the best way to minimize erosion is to build our soil structure.
Soil structure is important for many reasons. Soil structure holds soil particles together, resulting in a higher bonding strength and weight than individual particles alone. Clay particles are microscopic. Wind and water can very easily pick these up and move them thousands of miles away. Sand and silt are heavier and will bounce along the field and can end up in the ditch, a neighboring field, and enter our waterways. The more structured a soil, the more force is needed to move it. Tillage promotes erosion in 3 main ways. It buries protective residue, it cuts apart soil aggregates, and it can throw soil 30 feet. Tillage on sloping fields can move more soil than wind and water combined.
Wow, so tillage erosion is an important concept. To demonstrate this, we dug 2 soil pits. One was dug at the top of a 4% slope, and one was dug 130 feet downslope. This field, like many in the Midwest, has been tilled for over a century and has been subject to tillage erosion. Can you walk me through what you discovered?
Well, on first inspection, you'll notice the difference in the color of the soil piles. On top of the hill, there is some black topsoil, but the piles consist mostly of tan-colored soil, or what is called the subsoil. The opposite is true for the pit dug at the bottom of the hill. It has plenty of rich black topsoil and a little bit of tan subsoil. Once we jumped inside the pit, Hava Blair, a graduate student at the University of Minnesota in St. Paul, explained the difference between the 2 soil pits. First, she explains the pit dug at the top of the hill.
Well, one of the reasons we really love doing these soil pits is it's such a nice way to see what's going on underneath your feet. And so One of the things that you probably notice right away here is this dark layer that Jody was talking about, the topsoil. So in this pit, we have maybe 6 or 8 inches of that topsoil that's rich in your organic matter, holding on to your nutrients, helping hold on to your soil structure. And then Jody was also pointing out that in soils, we're really interested in color, because color can tell us a lot about the soil properties without even having to do a soil test. So we know when we see soil that's dark like this dark brownish black color, often really high in organic matter. And then as we see the soil get lighter in color, as we go deeper in the profile, you see the drop off in organic matter.
Now let's look at the pit at the bottom of the hill.
So first and most obvious, we have a lot more topsoil here. So the layer of this dark organic matter rich soil, carbon rich soil, I would say goes down to 12, 16 in some cases. So we have a lot thicker layer of that dark soil here.
As Hava pointed out, organic matter is black in color. As you can see, the downslope pit is darker in color and has 24% more organic matter in the upper 6 inches. From the 6 to 12 inch depth, there's over 60% more organic matter.
That's pretty interesting. I've seen the color changes before, but didn't realize how much the organic matter levels vary with both of these soils. So what does it mean for crop yields when plants are growing in the subsoil versus the rich black topsoil?
Organic matter supplies nutrients to the crop, especially nitrogen, phosphorus, and sulfur. It also gives the soil better water infiltration, holds water for the plant to use, and is a food source for soil microbes. This equates to better, more consistent crop yields.
In western Minnesota and the Dakotas, they have subsoils rich in carbonates. I heard that soil carbonates can create more erosion concerns.
Carbonates are a natural component of many of the soils we have here. The calcareous soils are easier to erode because calcium has the ability to separate soil particles from each other, again creating more individual particles that can blow and wash away. Carbonates are also an indicator of how much soil has eroded downslope, and Hava will explain this process for us.
The carbonate levels tell some of that story of erosion of soil moving from upslope down here. So 0 to 6 inches, we took that sample, sent it in. So we see 2.2% carbonates, and then this says 0 to 12, but actually that was a 6 to 12 inch sample. It drops down to only 0.7 carbonates. And so that's kind of interesting because you have carbonates here, not very much going on in the 6 to 12, and then you get another pick up in carbonates to 3.3 and then 16.8, which is like a lot of carbonates. That's pretty much to be expected down below. But on the top here where we have very little carbonates sandwiched between a layer of more carbonates, that tells me that we had soil from the surface, from the shoulder up there where we have less topsoil, generally more carbonates, moving down slope on top of what would have been the original land surface down below here that has lower carbonates.
So what do carbonates mean for crop yields when plants are growing in the subsoil versus the rich black topsoil?
Carbonates raise the soil pH. A neutral pH between 6 and 7 has the highest crop available nutrients and the best chemical environment for soil microbes. The black topsoil has a lower pH of 8 and maintain that pH to 2 feet into the soil. The tan subsoil started at the same pH but rose quickly to 8.6 to the 2-foot depth. A 0.6 change in pH means it's 6 times more alkaline. All of these factors mean that our topsoil has a much higher crop yield potential than the subsoil. Farmers with yield maps have seen that the eroded hilltops burn up quicker and yield a lot less than the low-lying areas.
We cannot control the weather or the slope and textures of our fields, but what I'm hearing is that reducing tillage or testing out cover crops will slow down the ability of the wind and water to move our soil downslope or off the fields altogether.
Exactly. We may not have a silver bullet, but we do have options. Our soil is our most valuable resource when growing a healthy and profitable crop. By planting cover crops, reducing your tillage, and improving your soil's health, you can take control of soil erosion and ensure the soil's productivity for future generations.
In the following videos, we will look at the management involved when introducing cover crops and reducing tillage in our fields.